Okay, welcome to part one, we'll call this, of week 4 in review. So at the start of week 4, I was teaching you guys how to use ECEL to predict um, reactions. So using ECEL, E0 cell to predict reactions. Now, in this particular type of question, which is question 3, 2011, you're using ECEL values. Well, you're not giving ECEL values, but you have to try and arrange these redox couples from highest to lowest reduction potential using the unbalanced equations. So you have to be given 3 equations, and you just systematically work your way through each of the equations to determine which species has the highest reduction potential, down to which species has the lowest reduction potential. And the key to doing these questions, and it's essentially the first step you take anytime you're approaching a redox question, is you assign oxidation numbers to everything. I just want to get a finer pen, so I'll use this one. Okay, so you assign oxidation numbers to everything. So this is uranium, elemental, so its oxidation state is 0. Then it goes to +3. Okay, so in the first equation, uranium is oxidized to +3, so it's oxidized. So if a species is oxidized, then it is not a very good, it doesn't have a very high reduction potential, because reduction potential is the potential of the species to be reduced. So if the uranium is oxidized, the manganese must have been reduced. And it's reduced from +7 to +2. So from equation 1, the manganese in permanganate was reduced from +7 to +2 in manganese ion itself, therefore having the higher reduction potential. And remember, in redox chemistry, the symbol for reduction potential is E0, and that's measured in volts. Okay, so now it's only one of the species that you need to choose. So the species you choose with the highest reduction potential is the permanganate, and the couple in this case, you would say the reduction of permanganate to manganese, that particular redox couple has a higher reduction potential than, in this case, we had uranium 3 plus being reduced to uranium. Okay, so that's what the first equation tells us. Then we look at the second equation. Now the key to figuring out what's going on in the second equation is to rewrite it, because they've sneakily wrote the two products and lumped them together. So this equation, if it was expanded out, would actually read uranium plus uranium 4 plus, and then you have two products. You essentially have uranium 3 plus and then uranium 3 plus again. Now if you look at the equation in that respect, you can see that the elemental uranium has an oxidation state of 0, and then going to +3. So from 0 to +3, that is oxidation. Whereas from +4 to +3, that's reduction. So equation 2, let's scroll down a little bit. Equation 2 tells us, since U4 plus was reduced to U3 plus, we can say that the redox couple of U4 plus being reduced to U3 plus has a higher reduction potential value than U3 plus being reduced to uranium. And that's from equation 2. And that only became clear when we expanded the equation out here. So U4 plus reduced to U3 plus, okay, higher reduction potential for that couple versus uranium and uranium 3 plus. So then we just need to take a look at equation 3. So we've done 1 and 2. 1 and 2 have helped us to relate the permanganate and the manganese coupled to uranium 3 plus and uranium. Equation 2 helped us relate uranium 4 plus to uranium 3 plus. And then finally equation 3, we better scroll back up and take a look at equation 3 here. So equation 3, again, assign oxidation numbers is the only way to figure these things out. So uranium 3 plus we have being oxidized, in this case, to uranium 4 plus. So that has the lower reduction potential value, whereas the manganese in permanganate is again reduced. So equation 3 tells us that permanganate, that couple has a higher reduction potential E0 value than the other couple. I'll just take a look again at the equation, and we have lost it there for a second. Just scroll back down. So the equation we were looking for, we were comparing permanganate and manganese versus uranium 3 plus and 4 plus. So equation 3 tells us that the permanganate couple is got a higher reduction potential value than the uranium 4 plus being reduced to the uranium 3 plus. So overall, we now know the correct order. So the order should be permanganate, manganese couple. The reduction potential value of that is greater than the U4 plus U3 plus couple. And then from equation number 2, we can say that the U4 plus U3 plus couple is greater than the U3 plus uranium couple. So that's how you approach answering those questions there, where you need to order redox couples based on 3 different equations. So just scroll back down and make sure you guys can see the end detail. Okay, so that's how you answer those questions, and you just got to make sure you systematically work your way through each of the 3 equations and assign oxidation numbers to determine which species is oxidized and which species is reduced. So in short, that's everything that was covered this week in week 4. And next week, week 5, which is our final week before the internal assessment in week 6. So next week, we're going to look at electrolysis and then do some revision in preparation for the assessment. So that was week 4 in review.